How exactly do we determine a virus's potential for spread? How do we know if an outbreak will die out on its own or become a pandemic and infect billions? The answer lies in understanding each virus's reproduction numbers. Every virus has reproduction numbers, which tell us, on average, the number of people each currently infected individual will infect. Think of it this way. Players are passing balls around. Each passes to two others. Then, the two players whom the first player passes to, each pass to two more. Each pass can be thought of as a new infection, so this scenario is similar to a virus with a reproduction number of 2, where each infected person would infect two others. There are two types of reproduction numbers. The basic reproduction number, called R0, and the effective reproduction number, denoted by R or RE. R0 is used at the beginning of a virus's spread. It assumes no one is immune and no interventions are taken. RE changes throughout a virus's spread and takes into account new immunity and death, as well as interventions taken to minimize spread. Both numbers are used to determine a virus's potential for spreading. When R is less than 1, the virus will die out on its own over a period of time. Players will pass less and less until there are no others left. When R equals 1, the virus will remain stable and new cases will be plateaued. Each player would pass to only one other player and so on, so passes are constant. And when R is greater than 1, the virus will spread very quickly. As players pass to more than one other, the total number of passes will grow fast. SARS-CoV-2, the virus that causes COVID-19, has an R0 of 2.2 to 5.7. This is why it spreads so fast. Reproduction numbers are affected by three factors. 1. The duration of infectiousness, which is how long an infected person can transmit the virus to others. 2. The probability of transmission between contact from an infected person to a susceptible person. This depends on the method of transmission. For example, it is higher for viruses transmitted by airborne droplets and lower for body fluids. 3. The average rate of contact between infected and susceptible individuals. This is highly variable and depends on countless factors such as housing, population density, social activities, etc. The first two factors are already determined through biology. However, the third is really important to understand and apply reproduction numbers. The average rate of contact can be changed using interventions such as social distancing and wearing protective equipment. This is how we can control the spread of a virus and bring R down to flatten the curve. Now that we understand how R numbers determine the spread of a virus, let's do our part to flatten the curve by social distancing, washing our hands, and wearing masks. We're all in this together, so let's make sure we can stop the coronavirus from scoring against us. Thanks for watching.